Okay, refraction. So for the first bit, we've got to identify the angle of refraction and the angle of incidence on this diagram. Well, for both angles, it's always between the ray and the normal, okay? Never between the ray and the boundary. So, the normal is there. Here's the ray. And this is the ray coming in, so that must be the angle of incidence. Here's the normal, there's the ray after it's been refracted, so that must be the angle of refraction. That's it. Which, according to the question paper, they've labelled that one A and that one D. Okay. Right, next bit. We have to work out the, what are we working out? The critical angle, given that the refractive index is 1.5. Okay, so what's the equation? Well, refractive index n is 1 over sine c, where c is the critical angle. And we have to work out c. So, as usual, rearrange the equation first to make c the subject and then put in the numbers at the very end. So, therefore, sine c is, bring that up here and the n down there, 1 over n. So therefore, c is sine to the minus 1 of 1 over n. Okay, we're ready to put the numbers in. So c is inverse sine of, n is 1.5, so 1 over 1.5. Stick that in your calculator and you get 41.8103 something. And it wants it to 2SF? Yep, that's right. So, two significant figures, well that's these two, so that 8 pushes that 1 up to a 2. So C is 42 degrees to 2 SF. Simple. Okay? Right, next bit. Okay, so here's an optical fibre, a very short optical fibre, and a pulse is sent in here, and it emerges sometime later here, but it's looking like that rather than like that. So the pulse is composed of both of light that's travelled down path A and path B. The point is that there's a lot of light in the pulse and it can go by path A or path B. All I'm saying is A and B are possible paths of the pulse. They're not different pulses. Okay. Right, what have we got to do? Right, we've got to explain why that turns into that. Okay, well, light that travels down path A is shorter than path B. That's the first thing to say. So therefore, light that travels down path A will emerge slightly before light that travels down path B, because path B is longer. They're both travelling at the same speed. So, therefore, the light in the pulse will spread out. Use that phrase, spread out. So that's it. That'll get you the marks. Path B is longer than path A. They enter at the same time. Therefore, light going down path B emerges slightly before path A, and therefore the pulse becomes spread out. And that's it. Okay, there we go.